Okay, so ready to dive into this world of quantum networks.
Absolutely.
It's like, those movies where they talk about unhackable communication?
Yeah,
It's not just sci-fi anymore, huh?
not at all.
We're going deep on this essay by Jürgo A. Schneppat. It's called Quantennetzwerke, die Zukunft der sicheren Kommunikation,
Oh, yeah, I read that one.
which basically means quantum networks, the future of secure communication.
Right.
It's like a peek into how we might be sending messages in the not-so-distant future. What do you think?
What's really interesting is that this isn't just a slightly better internet, Schneppat's essay makes it clear that quantum networks are a whole new way of thinking about how we move and process information.
This is not just about speed.
Not at all. It's about leveraging the strangeness of quantum mechanics to do things that are simply impossible with our current technology.
Okay, so maybe we need a super quick, quantum mechanics 101 crash course here.
Right. So imagine this. Our everyday computers use bits, which are like tiny switches, right? They're either on or off, 1 or 0. But quantum computers use qubits. And those are like switches that can be on, off, or both at the same time.
What?
That's thanks to a concept called superposition.
Wait, so a qubit can be a 1 and a 0 simultaneously?
Yeah.
That's wild. Does that mean it can process information twice as fast?
It's not exactly about speed, but about the possibilities it opens up. Imagine being able to explore many different solutions to a problem at the same time.
Right.
It's like having a massive parallel processing power boost.
Okay, my mind is already a bit blown. But Schneppat's essay doesn't just stop at quantum computers, right? He's talking about connecting them into networks.
Exactly, and that's where it gets even more interesting. By linking quantum computers together, we can create a network capable of tackling problems that are currently beyond our reach. Think drug discovery, materials science, even cracking the codes of the universe.
So we're not just talking about sending emails faster. We're talking about a whole new era of, scientific breakthroughs.
Exactly, and it's not just about the processing power. Quantum networks also offer a level of security that's simply impossible to achieve with classical networks.
Okay.
It all comes down to another kind of mind-bending concept called entanglement.
Okay, hit me with it. What's entanglement?
Imagine 2 qubits linked in such a way that if you change the state of one, the other instantly changes its state as well, even if they're miles apart.
Wow.
This connection lets us do some incredible things like quantum key distribution or QKD.
QKD. That sounds like something out of a spy movie.
It kind of is. QKD lets us create encryption keys that are impossible to eavesdrop on.
Really?
Because any attempt to observe them would instantly change their state, alerting both the sender and receiver to the intrusion.
So with QKD, hacking is basically impossible.
Pretty much, yeah.
That's incredible. But how do we actually build these quantum networks? Is it just a matter of swapping out our current cables and routers?
It's a lot more complicated than that. Building a quantum network requires completely new hardware, like quantum routers, which can direct the flow of qubits, and quantum repeaters, which can amplify the signal over long distances.
So it's like building the internet from scratch, but with quantum technology.
Exactly, and that's one of the biggest challenges Schneppat highlights in his essay. It's not just about the technology itself, but also the infrastructure, the investment and the expertise needed to make it a reality.
Right.
We're talking about a massive undertaking.
So is this even realistic? Will we ever see a world with global quantum networks?
Schneppat seems optimistic. He believes that with continued research and development, a global quantum internet is within our reach. But he also acknowledges that there are significant hurdles to overcome, both technological and societal. One of the biggest challenges Schneppat really digs into is this whole error correction thing.
Oh, right.
Well, see, qubits are incredibly sensitive. Incredibly sensitive to their environment. Any, tiny disturbance can disrupt their state and just corrupt the information.
So it's like they're super fragile.
Exactly. And unlike in classical computing, where we can just make copies of data to protect against errors, quantum mechanics throws us a curveball called the no-cloning theorem.
The no-cloning theorem, what's that?
Well, it's this fundamental principle that states you can't create an exact copy of an unknown quantum state, meaning we can't just duplicate qubits to safeguard against errors like we do with bits in our regular computers.
Okay, that sounds like a major headache.
Yeah.
So how do we deal with errors in quantum networks if we can't just copy the information?
Yeah, it's a complex field, but essentially we have to use these clever techniques called quantum error correction codes.
Okay.
These codes, they involve spreading the information across multiple, entangled qubits,
Uh-huh.
and then using sophisticated algorithms to detect and correct any errors that pop up.
So it's like a super advanced form of redundancy kind of built into the network itself.
You could think of it that way, yeah. And Schneepat points out that this is one of the areas where there's still a lot of active research and development happening. Creating robust and efficient error correction methods is crucial for making large-scale quantum networks, reliable.
Yeah. And what about the distance limitations? I mean, even with fiber optic cables, light can only travel so far before the signal starts to weaken. How do we build quantum networks that can span continents? Or even the globe?
Right, that's where quantum repeaters come in.
Okay.
They're these specialized devices that can amplify and extend the range of quantum signals.
Right.
They work by using entanglement to essentially teleport the quantum state from one location to another without physically sending the qubit itself over the entire distance.
Wait, teleporting, like in Star
Well,
Trek?
it's not quite as dramatic as that, but the principle is similar.
Okay.
It allows us to overcome the limitations of signal loss and build quantum networks that can stretch across, vast distances.
That's incredible. But I imagine building all this new quantum hardware and infrastructure can't be cheap. What does Schneepat say about the economic feasibility of quantum networks?
He acknowledges that the cost is a significant hurdle, for sure. We're talking about developing and deploying, cutting-edge technology on a global scale.
Right.
It'll require substantial investment from both governments and private companies.
But surely there's a potential for a huge return on that investment, right?
Yeah, absolutely. Schneepat argues that quantum networks have the potential to revolutionize entire industries, creating new markets and generating massive economic growth.
Yeah.
Think about the impact the internet had, right?
Yeah.
Quantum networks could be even more transformative.
So it's a high-risk, high-reward scenario.
You could say that. But the potential benefits are so vast that many experts believe the investment is worth it. We're talking about a technology that could reshape our world.
Okay, so we've talked about the technology, the challenges, the potential benefits, but there's another aspect Schneepat explores in his essay that I think is crucial: the ethical considerations. What are some of the potential downsides of quantum networks?
That's a really important point. As with any powerful technology, there's always a risk of misuse. Schneepat highlights several key ethical considerations that we need to address.
Okay.
For example, while QKD offers unparalleled security, it also raises concerns about privacy. If governments or corporations have access to unbreakable encryption technology, could that lead to increased surveillance and a loss of individual liberties?
That's a chilling thought. And what about access? Will everyone benefit from quantum networks, or will it just exacerbate existing inequalities?
Yeah, that's another key concern. Schneepat emphasizes the need for international cooperation and responsible regulation to ensure that the benefits of quantum networks are shared widely and that the technology is not used to create new divisions or exploit vulnerable populations.
So it's not just about building the technology, it's about building a better future for everyone.
Exactly, and that requires careful consideration of the potential downsides alongside the potential benefits.
Right.
We need to have these ethical conversations now while the technology is still in its early stages so we can guide its development in a responsible direction.
So there you have it. It's not all sunshine and roses. Schneepat reminds us that we need to be mindful of the potential risks as we venture into this exciting new frontier. What really resonated with me from this part of the essay is the sheer complexity of it all.
It's true. Schneepat's essay really drives home the point that quantum networks are this kind of multifaceted challenge with both incredible potential and serious risks that need to be addressed head on.
Yeah.
It's not just a technological problem, but a societal one.
Okay, so we've covered a lot of ground, haven't we? The technology, the challenges, all those potential benefits, and those ethical considerations.
Yeah, a lot to unpack.
Schneepat's essay really makes it clear that quantum networks are so incredibly complex.
Absolutely. But also incredibly promising, too.
Absolutely.
I'm still, trying to wrap my head around what this all means for the future, though.
Yeah.
What does a world with widespread quantum networks actually look like? I mean, really.
That's the million-dollar question, isn't it?
Right.
Schneepat, he paints this vision of a future where quantum networks are as ubiquitous as the internet is today. He calls it the quantum internet. And it has the potential to transform Like virtually every aspect of our lives, I think.
The quantum internet, that sounds straight out of science fiction, but what would it actually do? Would we just be browsing websites and streaming videos at warp speed?
Oh, it's so much more than just a faster internet.
Okay.
The quantum internet would enable like entirely new forms of communication and computation, that are simply impossible with our current technology. Think about like secure video conferencing, where it's physically impossible for anyone to eavesdrop,
Or distributed quantum computing, where scientists around the world can collaborate on complex simulations and calculations, all in real time.
So we're talking about a level of interconnectedness and collaboration that we can barely even imagine today.
Exactly. And it's not just about science and technology,
Yeah.
Schneepat believes that the quantum internet could also have a profound impact on fields like healthcare, education, even art.
Wow.
Imagine doctors performing like remote surgeries with the precision of quantum sensors.
Right.
Or students accessing these like immersive virtual learning environments that really leverage the power of quantum computing.
That's mind-blowing.
Yeah.
But Schneepat also acknowledges that we're still a long way from realizing this vision.
Yeah.
What are some of the key milestones we need to hit to make the quantum internet a reality?
Well, one of the biggest challenges is scalability, right?
Mm-hmm.
Right now, we're able to build small-scale quantum networks in labs, but connecting those networks together and scaling them up to a global level is a monumental task.
Yeah, I bet.
It requires overcoming all these technical hurdles,
Right.
like developing more stable, more efficient quantum repeaters,
Uh-huh.
as well as coordinating efforts across governments, research institutions, and private companies.
So it's not just about building the technology.
Right.
It's about building the infrastructure and the partnerships to support it.
Precisely.
Yeah.
And Schneepat emphasizes that this is going to require significant investment,
Yeah.
not just in research and development, but also in education and, workforce training. We need to build a quantum-ready workforce,
Yeah.
to design, build, and maintain these complex networks.
So it's a long-term commitment, but, the potential payoffs are huge.
Absolutely.
What's kind of stuck with you the most from Schneepat's essay?
For me, it's that sense of cautious optimism that kind of permeates the entire essay. Schneepat, he recognizes the enormous challenges ahead, but he also believes that the potential benefits of quantum networks are just too great to ignore. He really sees this as this pivotal moment in human history, a chance to kind of harness the power of quantum mechanics, to create a more secure, more connected, more prosperous future.
That's a powerful message.
Yeah.
And it's clear from his essay that Schneepat has thought deeply about both the technical and the societal implications of this technology.
Mm-hmm.
So as we wrap up this deep dive into Jorge Schneepat's essay on quantum networks, I'm left with a sense of both, like excitement and responsibility.
Yeah.
It's exciting to think about the possibilities, but it's also clear that we need to approach this technology with care and foresight to ensure that it, benefits all of humanity.
Well said. And that's a great note to end on, It's up to all of us to stay informed, to engage in these critical conversations, and to help shape the future of quantum networks.
Absolutely. So to our listener, we encourage you to delve deeper into this fascinating topic. Think about the potential impact of quantum networks on your own life, your work, your community. What excites you? What concerns you? The future is being written now, one qubit at a time. And that's a wrap on this deep dive